Joining us now in the studio, Professor Patrick Dasgupta is a professor at Delhi University. Thanks very much for being with us. Fantastic pictures. I'm sure you would have liked to have been on that plane.
Absolutely.
I certainly would have.
Absolutely.
So from a scientific point of view, why is today's solar eclipse perhaps a little bit more interesting than others which we've seen in the recent past?
Absolutely. The reason, of course, has been said again and again, is that this eclipse was the longest duration total solar eclipse of this century, while the next one, which will surpass the duration, is going to be in 2132 on June 13th. Having said that, the other most important point about this eclipse was the totality belt. It passed across many cities which were thickly populated.
Right.
So because of that, many people could witness the solar eclipse both in India, China, Japan. The third important point is one of the coincidences, is that this year is the International Year of Astronomy, and having a total solar eclipse of this duration falling in an International Year of Astronomy is, of course, a great thing.
It should be mentioned, sir, that solar eclipses by themselves are not that unusual at all. In fact, there's a solar eclipse once every 12 or 18 months, I'm told.
Absolutely, yes.
And there's going to be one apparently next year as well, but in the southern hemisphere.
Yes.
But what about the studies or scientific studies of solar eclipses like what we've seen today? What are scientists now looking to discover through witnessing these eclipses?
Right. We know that the sun above the chromosphere, which has a temperature about 6,000 degree Kelvin, just above the chromosphere is a thin ionized gas which is called the solar corona. It's very rare meaning density wise, it's rare. So therefore, when the sun's full disk is visible to us, one never sees the corona. It's only during the total solar eclipse, when the moon completely covers the sun, that one sees the corona. And the corona has a temperature of 10 to the power 6 degree Kelvin, 1,000 times hotter than the chromosphere. And one still doesn't understand why it is so. There are many theoretical models like magnetic loops coming out of the solar disk and pumping in very high energy particles into the corona and heating it, and so on. But only proper scientific data can tell us why it is so hot.
It would have been fantastic if there were a solar flare which coincidentally took place then, because that would possibly have been visible as well, because the edge that we see around the eclipse is not perfect by any means.
Absolutely. The flares, the solar prominences, if they could have been spotted, that would have added to the excitement.
Where does world science now stand as far as the sun is concerned? There is so much exploration of or desire to explore outer space. Even our own satellite, the moon, India has its own Chandrayaan mission. But what about the sun itself, and what really is the desire for scientists?
Sun being the nearest star, one can study a lot of physics of the sun. For example, one of the biggest problems of neutrino, solar neutrino problem, emerge by studying the neutrinos from the sun. Then there is another 11-year periodicity of sunspots. And one doesn't understand why there is this 11-year periodicity when suddenly on the surface of the sun you have these spots which are darker in contrast. And the reason is that these sunspots have tremendously huge magnetic field, and one doesn't understand how these 11 years cycle of sunspots appear. Similarly, the surface of the sun actually is not inert. It's, there is all kind of shimmering going on. There is a 5 minutes solar cycle, and a lot of interesting physics goes on even on the surface of the sun. So sun is not a mundane object. It is actually, it's bursting with a lot of interesting phenomena.
Tubar.com